Okay, let us start our discussion on local extrema and at critical point. We can say that whenever there is a curve algebra of x is given, see what happens. We are going to first find out the first order derivative and equate to zero. Then whatever if you find out the critical point x is equal to c, then that is c comma f. That f of c is can get point 2 point are there. Those are called, this is called critical point f c comma f of c, because at that point f dash of c is equal to 0. Maybe the, I can say that with that given point I need to find out the equation of the tangent. I will tell you the y minus y1 here, y1 is f of c here, is equal to m into x minus x1. Here x is again, m is nothing but the f dash of c, that is here f dash of c is equal to 0. Then we can say that x is nothing but the, maybe anything, x is x in the form of c plus h uh, minus c, that is h, you can say h into f dash of c, but we can say that f dash of c is equal to 0. The y value of the equation of the tangent coordinate is always f of c, and any point is means y values exceeds anything, the y will not go behind this, that is called equation of the tangent is f of c. This is very important in order to understanding. Now this equation of the tangent, y value at is nothing but the, for y coordinate of that tangent is always f of c. We will not cross it, okay, this thing at point c plus h, also the y tangent remains f of c only. Okay, now if you coming to the curve with the given, whatever the curve, if you want to find out f of c plus h, it is by Taylor's expansion f of c plus f dash of c into h plus f double dash of c into h square divided by 2 factorial. Therefore the f of c plus h minus f of c is equal to this one, f dash of c is equal to 0, this way. What it will give, this will give curve y value at c plus h. This f of c is nothing but the tangent value at c plus h is always given by f dash of c divided by 2 factorial into h square plus remaining term. Therefore the curve value at c plus h is nothing but the f of c plus h minus f of c. Similarly curve value at c minus h also, the same thing we can get here, f of c minus h minus f of c, that is always same. I mean the geometrical meaning, I can say that we are going to get the difference, the left side and right side are going to tell you. With that basic background, coming to the if they suppose if they given curve y graph of x and find out its first order derivative and equate to 0, we find out the critical point f dash of c. But that critical point f dash of c is equal to 0, you have assumed that three cases are possible, only three cases. One is f double dash of c is maybe greater than 0, f double dash of c is less than 0, f double dash of c is greater equal to 0. Case number 1, f double dash of c is greater than 0. As I told you, this difference in the previous f of c plus h or c minus h minus tangent value is always given by this f double dash of c plus 2 factorial into h square plus something is there plus 3. But the it is whenever I can say that it is f double dash of c is greater than 0 or is not, I can say that it is dominated by, whenever it is non-zero, it is dominated by this sign. Okay, whenever f double dash of c is not equal to 0, the difference is dominated by this term, the other is negligible, the whatever this other terms, their contribution to the this difference, sign difference is only dominated by this term. Okay, you can check with an example, no problem. In this case, in the left right side or left, if you coming to the left side, okay, H square is greater than 0, f dash of c is greater than 0. Definitely you can say that difference is greater than 0, means the function value is above the tangent. What it means, see here the left side, if you know that this is called, we want whenever the given equation, if we're going to find out the critical point c comma f of c, and f dash of c is that equal to 0, based on that if you can find out the critical point, and if we create, that is called, we can get the left side of c, that is c minus h, whatever the difference f of c minus h, means the function value at c minus h minus the tangent value at c minus h is always, the tangent value at c minus h is always f of c only, that is we know already how we know that. Then f of c minus h, while the curve value at c minus h and the tangent value c minus h is greater than 0, because here the curve value is like this, the tangent value is this, the curve value minus tangent value is greater than 0 here. Therefore the curve is concave up here, left side. And right side also, because f double dash of c is greater than 0, the h square becomes, even though h is here left side is negative, it is again the curve is again h square means positive only, the curve difference is positive, we can say that the curve is concave up around that point, we can say that, we can conclude that whenever the given curve. Coming to the second case, f double dash of c is less than 0, what happens in this case? Once if you find out the critical point, left side if you check it c minus h, whatever the function value, I can say that at c minus h, because and the difference is dominated by f double dash of c, and into h square divided by 2 factorial h square, even though h is negative here, h square becomes positive, but f double dash of c is negative, the difference is negative, you can say that the curve is below the tangent, we can say that. In the left side and right side, what happens, also the curve is below, because f double dash of c is also here negative, and h square becomes positive, and negative into positive you can get negative only, the curve is below the tangent in the right side. Therefore the, if double, suppose I can say that f double dash of c is less than 0, we can say that the curve is concave down at around that point c, the critical point c here, c comma if suppose, what we can say directly, if the given curve algebra f of x, and if you find out the critical point, and if f double dash of c is greater than 0, directly we can say that the curve is concave up around that point. If f double dash of c is less than 0, concave down around that point. If f double dash of c is equal to 0, and the other term f triple dash of c is not equal to 0, what happens in this case? The difference is dominated by the third order derivative. The left side c minus h, h is negative. This term h cube by 6 is becomes negative, and f dash of c, let us assume that it is positive. We can get the difference is whatever this less than 0. The curve is below the tangent. Okay, this is called concave down here. Right side c plus h. Okay, the right side, what happens, c plus h, this f triple dash of c is again positive, and the h cube is positive, the curve is, what I can say, above the tangent. Okay, concave up, means whatever the point is called inflection point, point of c, whatever this point is, c comma f of c is that point of inflection, we can conclude. But the thing is, again, if suppose, therefore the necessary condition for this one is f double dash of c is equal to 0, and f triple dash of c is not equal to 0, because once if it is again 0, what happens, the difference is dominated by fourth order derivative, the left side and right side is positive and negative according to the sign of f double dash of f fourth order derivative c. Therefore, this necessary condition is again if it is equal to 0, what happens, the difference is dominated by fourth order derivative, we can get like that again the same thing, the case of maxima or minima occurs. This is how we can understand the things. Again, if the fourth order derivative is also 0, then the difference is dominated by fifth order derivative. Again, then you can get the point of inflection. Means for order derivative, you can get point of inflection. If the odd order derivative is not 0, if suppose if the first second order derivative is 0, if third order derivative is not 0, you can get the point of inflection. This is how we can understand the things. Thank you.